Hey everybody, this is Gregory from Dapp University. So in this video, I'm going to show you how to use Web3.js for blockchain development. All right, so before we get into all that, be sure to subscribe to this channel if you haven't already and click the like button down below. And as always, if you want to learn how to build blockchain technology, you need to join my free training on my website or at dappuniversity.com/bootcamp. All right, so what I'm going to show you today is how to use Web3.js all on its own. And this is going to allow you to turn any application that uses JavaScript into a blockchain application. You'll be able to use smart contracts and also interact with the blockchain itself. All right, I'm going to show you some cool things inside of Web3.js today. So you won't have to use a Truffle project or anything like that. In fact, we won't even touch Truffle in this lesson today. I'm going to show you how to use Web3.js, just by itself with raw JavaScript, okay? So let's go ahead and get started. I'm going to use a smart contract today that I've pre-written, and you can find a link to this code down in the description below, okay? So we're just going to use Remix to deploy this smart contract, compile it and deploy it to a test blockchain, all right? So head on over to remix.ethereum.org to get started, all right? You can grab the code for the smart contract down in the description below, like I said, and go to the file browser here, all right? So create a new file here. I'm just using this untitled.sol file. I sort of keep this in here all the time just to sort of paste smart contracts in and use them. So really quickly, Remix is a browser-based IDE that allows you to create smart contracts for Ethereum, deploy them to any blockchain that you want to that runs Ethereum, and yeah, compile them, just test around, play with them, all that kind of stuff. And we're going to use Remix today to deploy this smart contract to our personal blockchain, okay? And you're also going to want to make sure you have Ganache installed, all right? So Ganache is a personal blockchain, and this is the blockchain that we're going to use in order to interact with this smart contract that I've pre-written. Okay, so make sure you've got Ganache installed on your computer. You can head on over to just Google Ganache blockchain, and you can find the setup steps pretty simply. All right. So go ahead and paste this in here, and notice I'm using Pragma Solidity version 0.4.24. What this is, it's a token smart contract, okay? It's already flattened, ready to go here. And this is Dapp token. I've used this in several examples on my videos on my channel, also inside my bootcamp. This is sort of the basic token for this channel. And it's a mintable token, it's a posable token. You see it's got a name, a symbol, and 18 decimals. So this is an Ethereum ERC20 token. So ERC20 tokens are just cryptocurrencies on Ethereum that are run by smart contracts. Okay, anybody can create their own cryptocurrency without creating their own blockchain by creating an ERC20 token just like this. Okay, so here's an ERC20 token done for you. Paste it in here. Go to the compile step over here in the new Remix. The new Remix UI. And make sure you select version 0.4.24, click compile, all right? And now you should see no issues here. If you do, make sure you select the correct compiler version, and you'll see the different smart contracts that were deployed. We want the Dapp token, so click that, all right? Actually not deployed, sorry, just compiled. All right, so Dapp token is here. And now let's actually deploy it. So go to the this little deploy and run transactions tab and select the provider. So this probably has JavaScript VM automatically selected for you. So you want to choose Web3 provider. All right. And then it'll say, are you sure you want to connect to Ethereum? No, click OK. And it's going to automatically populate localhost 8545. But we want to connect to Ganache on a different port. So open up Ganache and check your endpoint. So this is HTTP 127.0.0.1, 7545. So change that. All right. Click OK. And obviously, if Ganache is running on a different port for you, just use whatever port this is. And we're going to select Dapp token, all right, and deploy. There we go, success. So Dapp token was put on the network, and we can see the balance of this account actually went down. And that's because it costs some gas to deploy that smart contract. Yes, if you open Ganache the first time, if you're new to this, this gives you 10 accounts for free. Each one has some fake ether in the account. This isn't worth anything on the main Ethereum network. All right, so now let's use this smart contract inside of our Web3 environment. All right, we're going to use this token. We're going to mint some tokens. We're going to send some cryptocurrency around, and I'm going to show you how to do all of that with JavaScript by itself. All right, so before we do the JavaScript portion, make sure you have Node.js already installed. I'm going to go over here and go to Node-V. I'm using version 9.10.0, so that's working for me at the time of recording this tutorial. All right, so make sure you have this if you don't already. And I'm going to show you how to install Web3 and start using it. Okay, so now let's go to our command line here. I'm going to create a new directory. I'm going to say make directory, mkdir. Let's call this Web3 token. All right. Now inside of here, let's create a new package.json file. Well, first let's go into that directory, cd web3 token. All right, we'll say npm init. Walk through these setup steps. I'll say yes, 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 yes. Okay. All right, bump this font up so you guys can see it better. And now, let's see. I want to install Web3 like this. I'll say npm install Web3. And we'll say I'm going to say version 1.2.1. All right. And that's the version that I'll lock it at for this tutorial. I'll say -- save, so that'll put it in our package.json file. All right. All right, so I've got an issue here. I have PyEnv installed on my computer, so sometimes it switches the Python versions. So you want to make sure you're running Python version 2.7. So I'm going to say touch.python version. You don't necessarily have to do this step if you don't use PyEnv, but I'm just going to show you that I'm doing it in case anyone else has this problem. So I'll say echo 2.7.7 into Python version. All right, and say cat Python, version. All right. So the reason you have to have Python installed on your computer is because Web3.js relies on some Python-specific system dependencies in order to run the library. Okay, so let's try that again. npm install -- save. All right, it worked. All right, so now let's go ahead and create a new file to run our test examples. So I'll say touch app.js. All right, and let's see what we have in this directory so far, ls-l. All right, we can see we got an app.js, no modules, yada, yada, yada. All right, so let's go ahead and open this up in a text editor. I'm using Sublime Text, so I'll open it like this, subl dot. This is just a symlink for Sublime Text, so if you don't have this installed on your computer, it may not work for you. You can just open the project manually. All right, so inside of app.js, we're going to do a couple things. First, we're going to import the Web3 library. Do that like this. We'll say const web3 equals require. Sorry, web3. I can't type today. All right, save that. And then const, well, let me just show you. So Web3 documentation tells us how to get started. We can go to getting started and see here. Web3 equals new Web3, and then we give it a endpoint like this. So this is the RPC endpoint, which is the same thing as our Ganache URL. All right, so this URL right here, this is the same one we connected to when we connected to Remix. And this is how we create a new Web3 connection, and this will give us access to the blockchain. All right, so inside of here, we'll say const RPC URL. Let's do it like this. Equals this. Well, let's put it in quotes. All right. And we'll say HTTP lowercase. And then let's create the Web3 connection like this. Const Web3 lowercase equals new Web3 RPC URL. All right. All right, now let's just create a smoke test to make sure that everything is set up properly. So I'm going to go back to our file here, and I'll say, let's just get the latest block. Okay, so, the blockchain is made up of bundles of blocks that are chained together, and they have, they're contained in bundles called blocks. Each block has, information and a number. So let's just make sure that we're actually connected to the blockchain like this. We'll say, let's say Web3 ETH. All right, so ETH is a namespace inside the Web3 library that allows you to actually interact with the blockchain. We'll say get block. We can say latest. All right, and then set a callback function with 2 arguments, an error, and then a result. All right, this is an anonymous function we'll pass in here and say console log results. All right, so I'm going to run this in my terminal like this. Say node app.js, and make sure you do it inside this project directory. Okay. All right, there you go. So we can see that we're connected to the blockchain. Here's the block number, it's 23. Here's the hash, parent hash. So if you're just running Ganache for the first time, it'll probably be lower than this for you. Okay. All right, so that works. So now what I want to do is actually fetch this token smart contract and use it. Okay. So in order to use a contract, we'll use the contract library inside of Web3. All right. So you need a couple things in order to interact with the smart contract. You need the JSON interface and the address. All right. So basically, you need this thing called an ABI, which is just a big JSON array that describes how the contract works. And then you need the address. This is the address of where it exists on the blockchain. With these two pieces of information together, you can create a JavaScript representation of the smart contract and interact with it, call its functions, read information from it, write new data to it with the Web3 library. Okay. So let's get the smart contract ABI. We'll go here inside of Remix. If you go to the compile tab, we can select the token, Dapp token, and you can see this little ABI clipboard down here. I'm going to copy it. All right, then I'm going to go back to my text editor. I'm going to just paste it inside of here, and that's a big array, so I'm going to select it. And I have a plugin in Sublime Text that's going to allow me to do a cool trick here. You may not have this, so this may be harder for you, but you can look up a way to do this. So this is minify JSON. Boom, there we go. Puts it all on one line. So I say const ABI. All right, so we have the ABI, and now we need the address. So let's go back here and go to the deploy tab, and we can see the token, deployed contract right here. I'm going to click this clipboard, and that will give me the address. Say const address. What's this? All right. So now we can generate a new copy of the contract, just like the documentation tells us to do. New Web3 ETH contract. I'm actually just going to copy this to make it easy. All right, boom. So we'll say const contract equals this contract, and then we'll say ABI and then address. Boom, there we go. Console log contract. So let's run that. All right, like this. Boom, there we go. Awesome. So it worked. All right, now let's start interacting with the smart contract. So this is a token, and we're going to just check to see if it works like we expect. We'll just kind of read the name of the token, okay? So it's got a function called name, and that's going to tell us, what the name is, just like we saw here with Dapp token, right? We should expect this result. So let's go to our app and do it. So we'll say contract dot methods. All right, so all the functions in the smart contract live under this methods namespace, and I'll say name. All right, so this will give us the name of the smart contract, but this won't actually return the value yet. You have to say call. All right, so let me explain why. So in Web3, there are call methods and there are send methods. So I'll say call. After ETH call. All right. So you can do this on this method, or let's actually do it on the contract. Let's see here. I don't know exactly where that is. Yeah, ETH contract, my method call. There it is. Awesome. So what this does is it actually calls the function. Okay, so if I just put this, it wouldn't do anything. But if I do call, it returns the value. So there are two types of methods, call functions and send functions. Call methods are just for reading data. So in order to get the name, all we have to do is just fetch information. And that's because it's really easy. We don't have to specify who's calling this function. Anybody can do this, right? Send functions are a different story, which I'll show you here in a minute. You actually have to call .send. And you have to provide an address because it creates a new transaction. It costs gas. You have to pay for it, all that kind of stuff. But this is free. You don't have to pay for it. You can do this anonymously, and it's okay. All right. So I can call it like this. And then, of course, it requires a callback function like this. We'll say error result. And And then say console log results. All right, go to the terminal, run it again. There we go, Dapp token, awesome. And we can even say token name. Say token name. And then I'm going to interpolate this like this. All right, so this just allows you to execute JavaScript inside of this string. Okay, so these backticks allow you to do that, and use this dollar curly braces to put the value inside there. All right, there we go. Token name, Dapp token. Awesome. So that gets us started. Now, I want to use, I don't want to do this every time I call a function. I want to make this a little more brief. So if you see my other tutorials, you might have seen me use the async await pattern. So essentially what's going on here is all these calls to the blockchain don't happen immediately. The blockchain is kind of slow. And so in order to accommodate that, we use asynchronous programming. So in this case, we're using a callback function. We could also handle this with a promise. We could do it with async await. There's all kinds of different strategies for handling asynchronous function calls. You can read more about those just by Googling like async await or something like that. So I'm going to show you how to use that instead of having to do this every single time. So what we'll do is create an async function. We'll say async function, sorry, call it run. And here's where we'll put all the code. So we'll do this. All right. And then we'll say const, well, let me just recode it. Let's put this in quotes, or sorry, comment it out. All right, whoops, and it looks like I need this right here. Okay, so let's do results equals await contract methods name, and then we'll say console log. Let's do this. Token name. All right, so this should work, and it's the exact same thing as this, but we have to actually call this function. We've defined it. We haven't called it yet, and let's just do run here at the bottom. Run. Sorry, guys, I'm having a hard time coding today. It's a lot harder to talk and code than you think. All right, so didn't work. That's because we didn't actually do it. We do call. I just talked about that, and I didn't even do it. There it is. Awesome. Cool. So it works just the same. So instead of using this callback function, we simply did it with an async await. So that shows you how to do that. And I like doing this inside my script files because it makes things just nice and a lot neater. All right. So now let's do some more stuff. Let's actually get the total supply. So I can do that just like this. Let's do let result here at the top, because we're going to reassign this. And then we'll say result equals await contract methods total supply. All right, and this is going to tell us how many tokens exist. Right now it should be 0 because this is a mintable token. The tokens are actually created on the fly by the owner, which is the account that deployed the smart contract. So from this person right here. Okay. So let's see. Result equals await contract methods total supply call console log, and then let's actually log up total supply. All right, so the total supply is going to be this. Let's just do results. All right, show. All right, total supply is 0. That's what we expect. So now let's actually mint some tokens. All right. So who are we going to mint it for? Well, let's create some accounts here. Let's go ahead and track them in our app. Let's copy the first account in the list. This is going to be the token owner, which I just talked about. So const owner equals this. This is who's going to mint the token. And the recipient is going to be this person. We'll call this account 1. Const account 1. All right, go ahead and line these up here. And then now let's do const account 2. We're going to send some tokens here in a second. We'll send it to this person. Const account 2. All right, save that. So here's 3 different accounts for our scenario. So what we're going to do is mint tokens for this person, but the minter is going to be the owner. This is the person that actually deployed the smart contract. Okay, so we can mint tokens like this. let's say amount. Let's do let amount here. Web3, well, let's just do this, 100, let's do 100 tokens. All right. And we're going to do await, contract, methods, mint, all right? And this is going to be the function that we use to mint the tokens. So this function takes two arguments. The first argument is the number of tokens. This is going to be the amount. And the second argument is going to be the person we are sending them to. So I actually said that backwards. Sorry, the first argument is the recipient. This is account one. And the second argument is the amount. So account one, and then amount. All right. So what's really confusing is this token has 18 decimals. So what does that mean? Well, that means it's has 18 decimal places behind the zeros. So like, for example, $1 has 2 decimal places because it's got 2 pennies. Well, for a lot of tokens and, like the Ethereum cryptocurrency, it actually has 18 decimal places, or like 18, is the resolution for its pennies, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, right? That's how many decimal places there are behind the fractional token. So I'm going to copy that, 18 decimal places. So if you want to mint 100 tokens, you actually have to put in 18 decimal places behind it. There's a shortcut for this, which I'll show you in a second, but I just want to explicitly code it out here for a second. All right, so here's the amount, and here's the mint function. So whenever we were reading information, we use the call function and with Web3, but here we're actually sending a transaction. So in order to do that, we have to do send right here. All right, and I'll show you into the documentation. Let's see here, send. All right, so you can see here, send. So you have to call methods, my method, enter in the function arguments, and do send, and give it some options. So the options are, the account that it's sending from, the gas price, gas limit, and the value, okay? So in this case, only thing we really care about is who it's coming from. All right, so in this case, it's gonna come from account the owner. That's who's minting the tokens. So we'll say from owner. All right. So now that should work. I'll say console log. I'll say minted. Then I'll put amount tokens for say account number 1. And then let's do the total supply again. I'll just copy this, paste it. All right, let's run it. Hopefully I didn't make any errors. All right, boom, there we go. So we can see, here's the total supply is 0. Then we minted this many tokens for account 1, and then the total supply is now this. Awesome. Boom, it worked. So I'm going to refactor this a little bit. So instead of, hand coding out all these tokens with all these zeros behind it, we're going to use a tool for Web3 called Web3 utils two-way. All right, and we'll say 100. And essentially, we can use way because our token has 18 decimal places. All right, you can see that here, 18 decimal places, which is the same as Ether. So we can use the Ether helpers to work with our token as well. So it's not really way, but it's the same decimal places as way. So we can use the way helpers. All right, so that's going to give us the correct amount. And then we can also read it more human readable like this. Say Web3 from way, say amount, and we'll call it Ether. That's not really Ether, but for the same reason, we can use the Ether helpers to do that. And the same thing here, total supply, we can say Web3 from way, and then say Ether. So I'm going to copy that and then put it here too. All right, so hopefully I don't make any mistakes and copy them extra. Let's see. Okay, so I had an issue Web3 from way, so I got to do Web3 utils. Sorry, guys. Utils. Run it again. Boom, there you go. So total supply is 100 tokens. Minted 100 tokens for account 1. Total supply is 200 tokens. So I'm going to go ahead and add tokens to this so it's more readable. Run it again. All right, boom, there we go. So now we can see our console log, is just more readable. All right, so let's do a couple more things while we're here. The next thing I want to do is check the balance of this account. So let's say results equals await, contract, methods. Balance of is the ERC20 function that reads the balance of an individual account. We'll say account 1. Call. And then I'll say console log balance of account number 1. And I'll say Web3 utils from way. And we'll say results and ether. All right, so let's run that again. All right, balance of account 1 is 400. So now let's actually send some tokens to this second account, and then we'll check their balance and we'll see the final total supply, and that'll be the conclusion of our example today. All right, so you'll send new tokens like this. We can use the ERC20 transfer function. So I'll say results equals await, contract, methods, transfer, and we'll say account 2. Sorry, it's got 2 arguments. The first one is who we're going to, and then the second is the amount, just like the mint function, right? Sorry, typo here. And then we will do a send, just like we did with this function, with the mint function, but this time it's going to be from account 1, all right? Because we're going to go from account 1 to account 2. And we need to specify the amount. So do it like this, say amount equals Web3 utils, 2-way. Let's do 50 tokens. All right, so that's how we do 50 tokens. So we've got an amount. All right, and we'll say console log transferred. Let's pass in the number of tokens, Web3 utils from way. Say amount, ether. All right, tokens from account number 1 to account number 2. Okay, and then finally we're gonna check the balance of account number 1, account number 2, and then the total supply. All right, so account number 1, and then we'll do account number 2. And that should conclude our example. All right, so let's save it, let's run it. Boom, there we go. Awesome. So token name is Dapp token, total supply is 400, which is what we expect. We mint 100 tokens for account 1. Now the total supply is 500 down here, which we expect. So the balance of account 1 is 500. Then we transfer 50 tokens from account 1 to account 2. And now the balance of account 1 is 450, went down by 50, that's what we expect. And the balance of account 2 is now 50, which was 0 previously, all right? Boom, awesome. And the total supply didn't change, so that is exactly what we expect. All right, guys, so that concludes our example for today. That's how you can use Web3.js inside your own blockchain projects. You can turn any application that uses JavaScript into a blockchain application just like this. All right, so hope you all found that helpful. I've got some links down in the description below for the code. And also, while you're here, subscribe to the channel, like the video. And if you're serious about learning blockchain, you need to join my free training on my website over at dappuniversity.com/bootcamp. All right, until next time, thanks for watching Dapp University.